Hey folks, welcome to my channel Number Pen. So there we have the problem on our screen. Show that the following functions are not differentiable at the indicated value of x. F of x equals 3x for x lesser than 0, minus 4x for x greater than or equal to 0, and we have been asked to examine the differentiability at x equals 0, right? So the function undergoes a transformation as we move through 0, and that's where exactly we've been asked to examine the differentiability, right? So, which means we will have to go ahead and see what our left hand derivative and our right hand derivatives are, right? So, let's do that first. So, there we have our right hand derivative written for you on the screen. My right hand derivative, which I call by RHD, equals f dashed of x naught plus equals limit x h tending to 0 f of x naught plus h minus f of x naught divided by h, right? So what is my x naught? My x naught is 0 in this case, right? And because I've been asked to examine the differentiability at the point 0, so I can go ahead and substitute my x naught equals 0, and there we have an expression on your screen, uh, which we will have to further expand, right? So f of 0 plus h. Now, what is my f of 0 plus h? It is the function f of x when x takes a value greater than 0 by an infinitesimal h, right? And in that case, my x is greater than or equal to 0 is the equation that I will have to apply, right? So I will have to apply that equation when x is greater than or equal to 0, which means I will have to apply minus of 4x. And what is my minus of 4x? For the expression f of 0 plus h, it is replacing x with 0 plus h, right? And when I do that, minus of 4, 0 plus h, minus of f of 0. What is f of 0? It is the value of f of x when x equals 0, right? And when x equals 0, which is the function that f of x takes, it takes minus 4x. And what is the value of x for f of 0? It is 0, right? So minus 4 into 0 is nothing but 0. So divided by h, right? So which means my first part of the numerator is minus 4 into 0 plus h, which is minus 4h. And then I have a 4 into 0, which I can skip because it is equal to a 0. Then I'm left with minus 4h divided by h, which is equal to minus 4. So my RHD exists. There is a finite limit for f dashed of 0 plus, so which is equal to minus 4. Now let us go ahead and do our LHD. So there we have the LHD on our screen. LHD equals f dashed of x naught minus equals limit h tending to 0 f of x naught minus h minus f of x naught divided by minus h, right? And what is my x naught? Like we saw in our RHD, our x naught is 0 because that is where we are examining our differentiability. So substitute x naught equals 0 everywhere in this particular expression. And let's further expand this, right? So what is my f of 0 minus h, right? My f of 0 minus h is f of x when x takes a value lesser than 0 but by an infinitesimal h, right? Which means x is lesser than 0, right? So I will have to go ahead and apply f of x when x less than 0, and I get my 3x here, and my f of 0 minus h is nothing but my x replaced by 3 of, sorry, 0 minus h, right? And what is my f of 0? My f of 0 is what we calculated in our RHD. It is again minus 4x. So I have a minus of 4x, which is minus 4 into 0, which means I have a plus 4 into 0, right? And I still have my h in the bottom, which is a minus h, I'm sorry. So then I'm left with 3 0 minus h is minus 3h, right? And I have a minus h. right? So which means my h and h gets cancelled out, and I'm left with 3, right? Because my negative sign also cancels out. I have a negative sign in the numerator and 1 in the denominator as well. So we have our RHD and LHD, and I think I want to draw your attention for a minute to RHD, where my apologies, I made a small error which I realized when I was doing the LHD. So minus of f of 0, which is this part of the expression, right, is actually a minus of minus 4x, right? So this becomes plus, but it doesn't change the answer in any way. So there we have, folks, our LHD is 3 and my RHD is minus 4. And therefore we know what is our final answer. My LHD not equals RHD, and therefore the function is not differentiable at x equals 0. Right? So I hope you found this content useful. Please do subscribe to my channel and support. Thank you.